Let's look at some word problems. The Pythagorean theorem, a squared plus b squared equals c squared, relates to a right triangle. A right triangle must have a right angle. A and B are the two legs of the triangle that touch the right angle, and C is what we call the hypotenuse. So that's a key word. If you see a word problem that uses the word hypotenuse, then they're talking about a right triangle, and most likely you can use the Pythagorean theorem to solve it. The sum of the squares of the sides of a right triangle is equal to the square of the hypotenuse. So let's look at this word problem. The length of one leg of the right triangle is twice the length of the second leg. Now that's a sentence. So every time you get to the end of a sentence, you should try and write an equation. It said one leg, we'll call that A, is twice, 2 times, the length of the second leg. And again, A and B are the only legs of the right triangle. C is the hypotenuse. Now continuing with the second sentence. In the second sentence, we have the hypotenuse is 15 meters. So that means that C is 15 meters. Again, we got to the end of a sentence, so we write one equation. Now they want us to find the length of the two legs. So if we go back to the formula, a squared plus b squared equals c squared, and put in the values we know. We have a value for a, and we don't know what b is, and we also have a value for c. So since a is 2b and c is 15, we can put those into the equation. 2b squared is 4b squared plus b squared is equal to 15 squared is 225. So we have 5b squared is equal to 225. Solving for b, we can multiply both sides of the equation by 1/5 or divide by 5. And we have b squared is equal to 45. So we want to solve for b now that we've had the whole chapter 7 with the quadratic formula and everything else, we can use the square root property and take the square root of both sides. So our answer looks like b equals 3 square roots of 5. Now remember, when you take the square root, you should write plus or minus. But we're talking about the length of the side of a triangle. Could that ever be a negative length? So that's why I wrote 3 square roots of 5. 45 had broken down, and I did that. I always reduce my radicals. So 3 times 3 is 9, times 5 is 45, so I can take the 3 out, and that's what I did. But they want the length of both sides, so I got to put the b back into this equation and find out what a is. A equals 2 times 3 square roots of 5. So a equals 6 square roots of 5. Now this is a word problem. Make sure you end in words. The lengths of the legs of the triangle are 3 square roots of 5 meters and 6 square roots of 5 meters.